If you take a look at the tank behind me, you might notice some of these big gray black fish. Those are black rockfish. Black rockfish as adults can grow up to the size of about 4.5 kilograms, and they're voracious predators of smaller fish. But they don't start off that way. So when black rockfish are born, much like the other fish in this tank, they start out as fish larvae, about the size of the tip of your pinky fingernail. So one thing that I've been interested in my own research is how do you go from something so small to such an important ecological and economic asset as these fish? Well, why is a question like that important? Well, one thing that's important to know is that marine vertebrates like these fish are different from terrestrial vertebrates in some fundamental ways. First of all, when they spawn, they release not just one or two offspring, as you see in terrestrial vertebrates. They release hundreds of thousands, and in the case of this black rockfish, into the millions of larvae, into the water column. And when they spawn, they release into that water column, where they're subject to these winds and currents that are capable of blowing them along the coast and also off the continental shelf. That's a problem for these fish because when they're trying to get back to adult habitats to settle and join the adult population, it can be difficult to get back. So if you're a marine conservation manager and you're trying to spatially protect a population, as we're doing on the coast here in the California network of marine protected areas, it's important to know how organisms are entering or exiting the marine protected area, as well as how these really highly mobile marine fish larvae might actually be connecting multiple populations along the coast. We're hoping to get a better idea of how to protect these critical assets on our coasts and better understand how this early life history stage is an important part of that process.